When dealing with the temperature of a substance, it's very important to note which temperature scale you are using for your measurements. Conventionally, we're usually, on an everyday basis, here in the United States, exposed to the Fahrenheit scale. But in terms of the broader world, much of the world does not use the Fahrenheit scale. Much of the world uses the Celsius scale. So if you were to go on vacation and turn on a weather report, more likely you would hear the daily temperature, high and low, being expressed in Celsius. And so you need to remember this so that if they forecasted a day where it's going to be 32 degrees, if you're in a country that expresses temperatures in Celsius, you don't go out wearing a sweater. 32 degrees in Celsius would be quite hot. There's a third temperature scale that scientists like to use, and that is the Kelvin scale. And the reason that scientists like to use it is because it's an absolute scale, meaning that there are no negative temperatures in the Kelvin scale itself. The 0 point of this Kelvin scale is what's known as absolute zero, and it's the theoretic coldest temperature that any matter could be at. And scientists have come within the tiniest fraction of absolute zero. So if we need to convert between any of these three, the main ones that we convert between are Kelvin and Celsius and Fahrenheit and Celsius. And if you needed to convert between Kelvin and Fahrenheit, you would just combine the two equations. The nice thing about the Kelvin and Celsius scales are that the units are exactly the same size. 1 Kelvin unit and 1 Celsius degree are exactly the same magnitude. So the only thing that's different between these scales is their 0 point, where they start. What that means then for the conversion is that depending on what you're starting with and what you're solving for, you're either adding or subtracting 273. And technically the term that is actually used is 273.15, but for most purposes just using 273 or remembering 273 will be sufficient. So if we know the Celsius temperature and we want to know the Kelvin temperature, find out the Kelvin temperature, we would take that Celsius temperature and add 273 degrees. The Kelvin temperature is always higher in numerical magnitude than the Celsius temperature will be. If we know the Celsius temperature but we want to convert to Fahrenheit, what we need to do is take the Celsius temperature times 1.8, and then the product of this product, we add 32 to that. Conversely, if we want to know the Celsius temperature but we know the Fahrenheit temperature, we first need to subtract 32 and then divide by 1.8. And there's really no need to memorize both of these equations because they're the same, just algebraically rearranged. Taking a look at some practice problems. First question, what is the boiling point of water, 100 degrees Celsius, expressed in Kelvin? So if you recall that the Kelvin temperature is equivalent to Celsius temperature plus 273, if we plug in the boiling point of water in Celsius, which is 100, and add 273 to that, we find that the boiling point in Kelvin is roughly 373 Kelvin. Next question, what would the temperature 324 degrees Fahrenheit be when it's expressed in degrees Celsius? Well, the equation that we use when we know the Fahrenheit temperature but are looking for Celsius temperature is Fahrenheit temperature minus 32 divided by 1.8. So if we plug in our Fahrenheit temperature that we know, 324, we have this set up, and we should come up with a final answer of 162 degrees Celsius. Note that the significant figures for this one are determined by the original temperature, and in that numerator you're subtracting 32, but you still have the ones place being your least accurate decimal place. So there are three significant figures for when you do the division with 1.8, and the 1.8 is part of the defined formula, so we ignore those two sig figs for purposes of rounding. So our answer should correctly have three significant digits.